Hi everyone. Thank you for joining us today for another Simulation Moldflow webinar. Today Caitlin is going to be speaking a little bit about molding windows inside of Moldflow Insight, and we'll be covering kind of a quick demo on how to set one up and interpreting the results of it. So what I'll do first is start off with a couple polls here. We'll go ahead and launch this one first. Last month, Caitlin presented a webinar on meshing. We just wanted to see what your thoughts were on that, if you were able to attend it or not. As she mentioned during that webinar, she did present that information to Autodesk University this past year, so that's available online for you to view also. Okay, and it looks like about 50% of you, it's almost split, who was able to watch that last webinar here. So we'll go ahead and launch the next question. How many of you have used a molding window analysis before? And if you haven't used one before or not too familiar with it, that's kind of what today's topic is all about, trying to get you more comfortable with using these. Okay, we'll go ahead and close that up and take a look at it. Looks like a pretty good number of you are familiar with it, and then there's quite a few that's also pretty new to the subject, so it'll be great to see if this information helps you out and see what questions come out of it. All right, and then let's just go into the last question here. If you've not used a molding window analysis before, what is the main reason for not running one? Just time consuming, don't really understand the results or how to set it up, doesn't seem accurate to you, or this doesn't really apply to you and you're a frequent user of it. Give it another minute or so here. Okay, go ahead and close that poll up. And looking at this, there's a good number of you that used it and then a good number that don't really understand it. So hopefully this will be helpful to those who don't understand it, as well as those who use it frequently, maybe open up some new tips and tricks for using them. So thank you for answering those for us. It'll help us kind of key into the presentation here. At that, what I'm going to do is pass it over to Caitlin. She's a product support specialist for Simulation Moldflow, and she'll let you know a little bit more about molding windows.
All right, thanks Kristen, and welcome everybody. Thank you for joining today. Can everybody hear me? Can you hear me, Kristen?
Yep.
Okay, perfect. Awesome. So today we'll be going over the molding window analysis, and as Kristen mentioned, about 40% of you don't understand it or the purpose of it, maybe results interpretation, so we'll go over that as well. So as always, just a reminder, we do post these recordings on YouTube under the Autodesk Sim 360 channel. I do want to go ahead and apologize if you did attend the meshing webinar. I haven't had a chance to get that one up to YouTube, but that is on my list of things to do this week. So you'll get 2 YouTube videos and an email sent out to you, hopefully. And then additionally, for those of you who don't know and are new to the webinar series, we do announce in the forums, we send direct emails, then you can also find it on Twitter, Facebook, and LinkedIn. We like to us specialists, I guess, create different articles based on cases that we see. So, so for February, we have week 1 and week 2 articles that you can always reference. And again, we do create those. Myself, Kristen, if you've worked with Paul or Burned on the mold flow side, and then on the CFD and mechanical side, those product support specialists also create these sorts of articles. So, so you can always find those on the forums. So next, we'll just get into today's agenda real quick. We'll do a quick introduction, the benefits of a molding window. We'll walk through setting one up. We'll do a demo, and then I do have the results interpretation in this PowerPoint. So what is the molding window? It defines the limits of molding conditions under which an acceptable part can be produced. It's also referred to as the processing window. And then from this analysis, if the molding conditions fall from within the region, which we'll look at later, you can determine if a good part can be made. And the goal of the molding window is just that, to find the optimal molding conditions. So next we'll run through the benefits. So one of the benefits of the molding window is that it runs quickly. Typically it runs within minutes. In today's demo, you'll actually see it ran within seconds. So a lot of it will depend on the size of the part and what you're trying to do, but it's a pretty quick analysis to run, and it isn't too time consuming. And then it sort of helps to answer questions like, will the part actually fill? Is the pressure low enough? This should be at least half the machine's pressure capacity. Another question is, what is the number and position of the gates? You want to add gates to reduce the pressure, and an analysis is run with each gate configuration, and the effect on pressure, shear stress, temperatures, etc. can be compared at these different locations. How big is my molding window? A small molding window indicates that it will be difficult to produce the part, which typically is because you have high pressures. So how can you reduce that? Maybe you need to add more gates. What material will work best? You can analyze different materials for each part or for a single part. And then lastly, can the part wall thickness be changed, and how thin can you go for the part thickness? You can quickly see decreasing the wall thicknesses increases the pressure to fill, and that sort of thing too. So, and then lastly, you're able to determine the part's cooling time. So to set up the molding window analysis, these are some of the inputs. It's run with either a dual domain or mid-plane bottle, single cavity. Just due to the assumptions that the solver makes, no runner or feed system is required, and if you do try to run with it, it'll likely fail. The analysis sequence is the molding window, obviously. As I mentioned, you can have one or more injection locations. You want to choose a plastic material, and then there are a couple of the process settings that you'll want to adjust that I'll also go through. So next, we have a flow chart, if you will, of running the molding window. This might be pretty familiar to many of you. Basically, you want to import your model, check the mesh, then you'll set up your molding conditions or your machine pressure limit and different factors and whatnot that we'll also go through. You'll run the analysis, you'll look in the log file to see if the analysis recommends a good injection time and mold and melt temperature. If not, then you can look through the results and determine if you need to make any changes. So as I mentioned, there are a couple process settings that you're going to want to change. In this one, we have the injection molding machine set as a default. If you do know your injection molding machine, you can change that. In this case, I don't know it, so I left it as is. So in instances where you want to leave it as is, you want to change the under the hydraulic tab, change the maximum injection pressure to about 140 megapascals. The default is set to 180. That's higher than most molding machines, so 140 is a safer assumption. If you don't change the maximum pressure, I apologize for that. As I was saying, if you're not changing the maximum pressure to the limit of the molding machine, only really influences the molding window or the zone plot. And so this is just something to be aware of. If you don't change it, you will have to take this into consideration later on. Additionally, right in here, you do have the ability to change those, and we can show you in the software itself. Right now, the default is set to automatic. I usually leave it there, but most instances, the only time you would really want to change this to specified is if you want to evaluate different materials on the same part. Also in the process settings, you can change the advanced options. So here you would want to change your injection pressure limit to 0.8, so that's about 80% of the capacity. This is under the feasible molding window. So under the preferred molding window, it's recommended to change the flow front temperature, the drop limit, to 20 degrees. This is generally acceptable for most materials and applications. I think the default is actually set to 10 degrees. So that is a bit conservative. If that's the route you want to go, that's all right too. One thing to keep in mind is this model doesn't account for hesitation that occurs in the thin areas close to the gate, but it does take in thickness changes. So that's just something to keep in mind. And then it also doesn't work well with runners, as I mentioned earlier, for shear heat up and build up that you would have in those areas. So that's why we kind of recommend the 20-degree. We have for the flow front temperature rise limit, a 2-degree increase. That's generally best to just keep that one at 2 degrees. The default, I think, is 1, or it changes per material. But increasing more than 2 degrees, you start to run into material issues. So, and then the injection pressure limit under the preferred molding window, we changed that to 0.5. As I mentioned earlier, you want to keep this about 50% of the machine's capacity, so it's a good starting point to have there. So next we'll just go into a demo. Any questions before we get started in this, Kristen?
None right now. Just to remind everyone, if you have any questions throughout the presentation, feel free to just write them up in the questions tab, because Paul and myself are kind of answering questions live, as well as if there's any good ones to bring up to the entire crowd, we'll interrupt Kate and kind of start a discussion on it there.
Yeah, and we like to keep these interactive, so we welcome all questions. So as I mentioned, you want to import your CAD geometry. It is a single cavity. Here you'll see I have two parts. So really what all I'll do is I'll just turn off one of the CAD bodies. So then next, as always, we just kind of work left from right, or you can work down through the study tasks pane. Moldflow outputs is okay. If you notice, this is a dual domain, so you'll want to use the mesh match. For the sake of time, I went ahead and created one. So visually looks okay. You can always check the mesh statistics. So you'll scroll through here. Not the best. This part does have some rounds and features that we could eliminate through CAD Doctor if you have CAD Doctor, or you could get rid of them in your CAD package. So that's pretty simple. Next, you want to change your analysis sequence. You'll see molding window is right here. If you don't see it in here, then you would want to just go to more. Again, this is only for a midplane and dual domain. So if you tried to run this in 3D, you wouldn't see this molding window option. I think you'd just see the gate location. So yeah, we changed that. For the sake of the analysis, I'm just going to keep the material to the general polypropylene. This is a handrail clamp, so I'm not entirely sure what the material would be, but like I said, for this analysis, a polypropylene will work. You'll want to set the injection location. So that looks good. I'm going to turn off that and just leave this shape open. And then we'll go through the process settings. So as I mentioned, if you know your machine, you can always select yours being used. Or since this is a quick analysis that provides a rough guideline or a general guideline, a good starting point, you might be able to get away with using the defaults. So you want to come in here and change this to 140, as the 180 is typically at the very high end of most machines' pressures. Here's where you could go in and change the specified. Again, this would only really be necessary if you want to change or analyze multiple materials on one part. And then we'll go through here and change these settings. Whoops, sorry about that.
Hey, Kate.
Yeah.
We do have a good question in here from Mike. He's asking, whenever you chose the injection location there, he's wondering what reason would there be to not run a gate location analysis first?
That is a good question.
And I think it kind of goes into when you run the molding window analysis, it'll give you some suggestions. Is that right, Kate?
Mm-hmm.
Just for kind of the best location where you could possibly put in multiple gates in there.
Yeah. And again, this also has to do with So the gate location analysis gives a good idea of the pressures through the runner. This gives a good idea of how much pressure will actually take to fill the part itself. So that's why you would kind of want to use the molding window analysis, is because it gives those sorts of guidelines, how much pressure will fill the part versus not just the gating information. Does that make sense? And then I also see Anik has a question in there. Would this work with multiple injection locations? Yeah, you can use many injection locations. For the sake of today's, I'm just going to run one, but you can run more than one. So, are we good there?
Yep, thank you.
Alrighty, perfect. So yeah, we will go through and we can change these 0.8, 20 to 5. And we would just hit OK, OK, and then we would start the analysis. And as you'll see, this will not take very long, or it shouldn't anyways. I have run one already. So about 10 seconds it took. So it doesn't take too long. And then you just want to kind of go through and look at the results. Sorry, having mouse issues over here. So in the analysis log, once it's finished, you'll want to look at these three recommended mold temperature, melt temperature, and then the recommended injection time. And you'll kind of want to take a mental note of that. I am actually going to write it down. I think that always works best. So we have 80 degrees Celsius, 196 degrees Celsius, and 0.335. And you'll notice those are pretty exact numbers. And also, one thing you'll see, which I'll scroll up in 1 second, is that these numbers tend to range on the higher end of the recommended, or the settings of the material and whatnot. So if you remember, 80 degrees C was what the recommendation was. That's on the higher end of the mold temperature. So if you needed to adjust that, that would probably be okay. That's something we can look, though, when we go through the results. Additionally, the 196 falls kind of in the middle, lower range, and then the injection time is 0.355, which is 3355 rather. It's pretty exact, so if that needed to be altered a little bit, probably could, but again, let's check out the results to make sure. So here we have the zone plot. It's probably the most easiest one to actually tell, in my opinion, if your analysis is going to be okay. You'll want to go in here and change your cut axis to the mold temperature. Hit apply, hit OK. And then this green is where you want to have your your preferred settings. The red, or the yellow rather, is feasible, so it'll be okay. You might run into issues, you might not. And then red is not feasible, so I wouldn't recommend using that. So based on what the analysis log output gave us, we'll come in here and we'll do examine. Let's see something. So it has the mold temperature set to 50 up there. But if you come into here and you have your melt temperature at 196, so we'll call it 190, and then your injection speed 0.3, round it up to 0.5. Oops. So in this area, so you'll notice that this is good. It's green. To confirm that even further, we can look at the pressure drop result. So again, you're going to want to come in here and change your axes. I'm just double checking that on my machine. So we'll call the mold it's about 160, 196. The injection speed was about there, and we'll want it to look like that, and then we can adjust the mold temperature if we needed to. The high end was up here, so we'll just leave it like that. And then again, you'll come into your examine, and you can examine this point. So the optimum injection point indicates the pressure required for the optimum condition. So you want to just ensure that it's under the 50 megapascal, which should be, because that's what we set in the process settings. So really, any of these would be okay, but again, you wouldn't want to have an injection time up 10 seconds. That's pretty long. And so about in here would be okay for this one, and then again, that's less than the clamp tonnage, or injection pressure rather. So then next we want to go into the temperature plot, and then we would go through and change your axes here also. And then come up here, and then you want to have the best injection time is going to be when the flow front is equal to the melt temperature. So you could come in here and say a 0-degree drop in temperature defines the highest quality. So about here, and just mark these. If you want to drop it to 10 degrees, that defines an acceptable. So, and that's about a 2-second injection time. And then if you dropped it down to 30 degrees, this is probably the preferred molding window. So it's assuming it is set at the maximum temperature drop. in the advanced options. So finding a time these temperature occurs gives you just another way in a sense of the molding window and how the flow front temperature is generally being found. So these three results are the ones that we commonly look at. Visually, I find this one to be most useful, but it is good to go through because you're going to want to know what the pressure drop maximum is and the temperature at the flow front. And then additionally, you can look at the cooling time to be able to find out what cooling time you might need for your analysis. And again, these are it just provides a really good starting point for your simulation in the beginning stages. These might need to be altered down the line as you add your feed system and cooling channels and all that stuff, but in the beginning stages, using the molding window analysis is a good starting point to give you just an overall idea of how the part might fill and the sorts of temperatures and injection speed that you might need to use it. So that's really all that I have.
Sorry, Kate, I think you cut out for a minute or so there. But it sounds like we're just kind of wrapping that up now then?
Yeah.
Right?
Yep, I was just saying I didn't really have any more to go over. I didn't know if there was any more questions. Looked like Anik asked if we're able to use this with sequential valve gating, and looks like he answered that, but yeah, this is just used for injection cones only. Yeah, and
the reason for that is just because what you're really doing is trying to find the optimal kind of general area of placing that injection or feed system. So typically we don't recommend creating the entire feed system until you get further into running the next step in the analysis.
Yeah, that's absolutely correct. And then again, just the general assumptions that this solver uses doesn't accurately take into account feed systems anyway, so I just wouldn't recommend doing that. And Harold asks, is this usable for rubber too? I am not 100% certain. I was looking into that. I think it might just be thermoplastic materials, but that's something that we can double check on for you, unless Paul or Kristen knows off the top of their head.
I'm not aware of it. However, we could certainly take a look at it, as Kate mentioned.
Or
Harold,
if Harold wanted even, if there was a rubber that you use frequently, or you might try to run it on your end also, but to see if it works and the sorts of results. I'd be interested in knowing that myself. Okay, great, Harold. Thanks. Mike Hoyt mentioned that it is good to use as an initial material comparison, one material versus another. Yeah, if you do have multiple materials that you want to use, then definitely on one part too, definitely is a good comparison tool. Ollie asks, is there a database or generic sample injection machine we could use or look at the details? Let's double check the software. So the one that's in the software is just the default material, but we can go ahead and look at the information. Additionally, if you have in mind an injection molding machine, we do have about 1,100 in here that you could take a look at. If you had certain criteria, you might be able to look for that. You can add filters, and if there was a specific manufacturer or something, you could go in here and change and look to see if the one you want is in there. So that's one way to search quicker, if you will.
And Kate, I just wanted to bring up kind of to your point there, using the database there. If you go under the Tools section, there's also, you can search for all the kind of default inputs in Moldflow, so machine settings, custom materials, and so forth you can find in there. We actually have a previous webinar that we hosted just describing the databases and possibilities behind them. So it'd be great to reference back to that one, which is on our YouTube channel also.
And I also just got word from Paul clarifying Harold's question. The molding window works well with all different materials and different injection locations, so you should be okay. But if you wanted to double check that, Harold, you could. We have a question, how reliable is the molding window analysis for a thick, chunky part? Which 3D meshing would be more applicable? Again, the solver is based on the midplane and dual domain, so you might run into issues. I know when I was just toying around with the software myself, you'll actually notice, I apologize, you can't see it on any of these ones, but the data towards the end will actually start to go crazy, if you will, be very skewed, and it's just really the solver's crashing. So again, this is for midplane and dual domain, so you might see some issues doing that with 3D parts.
Yeah, and that's where you would almost want to just make sure you keep an eye on like the match percentages. I know that for this part it was a little bit lower than typically recommended, but probably just review that a little bit further and then make sure all the thicknesses kind of look okay whenever you're initially meshing your part.
Mm-hmm. Right. Renan, sorry if I mispronounced that, asks, is ASMA, is it possible to use two materials in the same study for comparing a molding window? And then the same question for Insight. I guess I don't entirely understand your question. In the same study. you would need to create another study, so have a duplicate study in here. You couldn't come in here and have like generic polypropylene, generic PVC. You just need to create duplicates or copies of the study and rerun it.
Hi, Caitlin.
Hey, Paul.
I'm on mic now.
Okay.
Yeah, what you could do is you could run one study, then a second study, and split the screen so you've got both.
Oh, right. Yep.
And then, if I believe rightly, the good way to compare is to scale. I think you can scale both charts to compare the two. I'm not 100% sure.
Yeah.
It's been a while with Molding Window.
Yeah.
But otherwise, the best way Molding Window is used is really when you're comparing more than one. Running a Molding Window is good for saying for that gate location, these are the ideal conditions, rather than using the default conditions. If you then run with two materials, it gives you something to compare, which is the better Molding Window. So that's compare materials. Two gate locations, you'll probably notice lower pressures, etc. So that's where Molding Window comes into its own. It's when you're starting to look at more than one study or different materials, different gate locations as well.
Okay. That makes
But
sense.
yeah, that question, yeah, just split the window with two models and look at them side by side.
Thanks for that, Paul, for clearing that up. I'm sure that answered many questions or for several people. Are there any other questions? If not, probably wrap it up here and let you guys have the rest of your day back.
Yeah, it looks like no more questions are coming in right now, but we would like to extend, if you do come up with any questions or if you want to go try it on your own and come up with some questions along the way, what you can do is post them to our forums for either Insight or Advisor, depending on which one you're running. And then we'll be sure to keep an eye on it. Just watch out for those questions, see if anyone needs any additional help there.
Alrighty, well, I will go ahead and end the webinar now. I will, like I mentioned earlier, I'll send out get the YouTubes created and up on, the webinars created and up on YouTube so everybody can reference that later on. Thanks for joining, everybody. It's nice to see some familiar names in here and participating. We really like the feedback and just being able to answer questions live. It's pretty helpful for everyone, I think. So with that, we'll go ahead and end the webinar.